Hello everyone, welcome back to Great Expectation Mathematics Tuitions. We are doing a series of videos on probability in maths literacy. So I'm Mr. S. Dionaran and let's get started. Okay, we're back. So in our last video, we concentrated on the basics in probability, and now we're going to move a step up in terms of our probability section for grade 12. You will recall that the formula for probability is equal to the number of favorable outcomes over the total number of possible outcomes. So you need to keep that in mind at all times. If you look at an example that we have here, we have a bag that contains 5 red balls and 7 blue balls. Calculate the probability of picking a blue ball. So if you recall, our formula says that the number of successful outcomes. To pick a blue ball, the chances are 7 successful chances. Remember, we're picking one ball. So we have 7 possibilities of picking a blue ball. And the total number of outcomes or ball in the bag is 7 plus 5, which is 12, as you can see in our solution. So the probability, this is how we write it, P of blue, meaning picking of the blue ball, probability of blue ball is 7 over 12. I'm sure you found that example easy. Now, it's important to understand further that in probability, we get a theoretical probability and an experimental probability. So what is the difference between these two terms? The theoretical probability is the one we've been doing all this while, where we use known facts about the probability or the situation. For example, in spinning a coin, we know that the prediction of getting a head would be 1 out of 2. So this is called a theoretical probability, and this is equal to 50%. In theoretical probability, as the word suggests, it is in theory that out of every spin that we get, or the number of spins, then half the number of spins will be heads and half the number of spins will be tail. But that is theoretically. But in reality, does that happen? Let's look at what we call experimental probability. This is found by repeating the event many times, by doing many spins of the coins, or trials we call it. This would be called experimental probability. So coming back to that example, if we spun the coin 500 times, and in getting a head, when you counted the number of times you got the head, it worked out to 260 out of 500. Now, if you look at 260 divided by 500, it is slightly more than 50% or half. So this tells us that in theoretical probability, it's telling us that it should be 50%, but in experimental probability, when we actually do the trial, it could work out to more than 50%. So we must take into account that probability is only a prediction. It is the likely chance of an event taking place or that situation taking place. So as we said, this here is more than 50%, greater than 50%. And that means that what can happen experimentally may not happen theoretically. So that is the difference when we talk about theoretical probability and experimental probability. You would see an example that where we have experimental trials taking place. Sometimes they do like over 1,000 trials to see what is the outcome of that probability. And the more trials you do, the closer you would get to the theoretical probability answer. Okay, let's look at page 4, which is now certain questions on probability. The question states, if 5th October 2018 is on a Friday, what is the probability that 11th October 2018 is on a Thursday? What would you say your answer to that will be? Give you a few seconds to think about that. Well, you would say that 5th October is a Friday, so the next Friday obviously will be, yes, the next Friday will be 12th October, 7 days time. So obviously the probability of 11 October being a Thursday would be 100%. So that was simple. If we look at our next question, Peter standing in a queue in a candy store in the front. There are 50 chocolates that are wrapped up as follows. Now, as you can see, it's important to mention that he is standing in front of the queue, because if he was not in front of the queue, then the number of chocolates would decrease, and that would affect the total number of outcomes in the question. So for this one here, we know that there are 50 chocolates now on the shelf, and they are described as 17 silver, 20 gold, and 13 red covered chocolates. What is, as a fraction, the probability of him getting a chocolate in a red foil? So we know that the total number of outcomes is 50. The number of successful outcomes for red is 13. Correct. So you would say that it is 13 out of 50 to get a red chocolate, a red foil chocolate. Simple. Let's look at 2.2. What would be the prediction of him getting a silver foil chocolate? Again, we have 17 silver foil chocolates out of 50. What would be the prediction of him getting a gold foil chocolate? Yes, gold would be 20 out of 50. So this is how we have written it in a fraction form. Now the next question, 2.4, asks you, what's the prediction of him getting a silver or a gold foil chocolate? If we look at our answers above, we could work it out from there. So the prediction of getting a silver or a gold foil chocolate would simply mean we add the probability of the silver plus the probability of a gold foil chocolate, which would mean that we add our two fractions. So it's 17 out of 50 plus 20 out of 50. And if we add that, if we use our calculators or we use common fractions, we will get 37 out of 50 is our prediction of getting a silver or a gold foil chocolate. Now 37 out of 50, we also need to look at the answers and make sense of it. 37 out of 50 is in percentage form is 74%. And this tells us that there is a higher probability of him getting a silver or a gold foil chocolate because now he is looking and choosing one of the two foil chocolates on the shelf. That's why our answer is very, very high compared to the previous ones, where if you look at the gold foil chocolate on its own, that probability is only 40%. The silver foil chocolate on its own is only 34%. But if we combine the two, then we see that the chances now are 74%. In 2.5, what's the prediction of him, probability of him getting an orange foil chocolate? Yes, I'm sure you were able to understand this one. It would be 0 because there are no orange foil chocolates on the shelf. So that's a good problem for you to understand with your probabilities. Let's look at question 3. So it tells us in a car park, there is 5-6 probability that the cars parked at random is made in Japan. If there are 192 cars in the car park, determine how many cars are not made in Japan. So the key here is cars that are not made in Japan. So if 5-6 are cars made in Japan, we would first calculate what fraction of cars not made in Japan. So the fraction of cars not made in Japan would be 1 minus 5-6, which is simply equal to 1/6 cars not made in Japan. 1/6 of the cars in the car park would not be made in Japan. But how do we get the number of cars of this total? Very simple. So the probability of the cars, if we want to determine the number of cars not made in Japan, so the number, that's what they ask us, the number of cars now would be 1/6 of the 192, which if we use our calculators is 36 cars. So of the 192 cars, we see that 36 cars are not Japanese. So that is also a nice, good example, and it shows us a real life example that where we could use our probability knowledge. Now, learners, I'm going to look at a lotto question, which is, as I explained at the beginning, is part of your curriculum in probability. So let's look at this question. Right. Here we have our lotto question. Now, In South Africa, we have the National Lottery. I'm sure many of you are familiar with. Obviously, gambling is not for persons under 18 years old. And you know people who take the lotto. The numbers that are in the lottery is from 1 to 49, and you need to select six winning numbers from the 1 to 49 in order to win the national lottery. And these numbers can be selected in any order, which means you do not have to give it in ascending or descending order. And here you've seen a draw that is being made of a lottery draw, and these are the five numbers drawn, and the 28 there is the bonus number that you could see. In the next one there, we have also a draw, and there are six numbers drawn with the bonus number. Now, in terms of the second one there, it's now arranged for you. So that one there is now arranged in ascending order. That's what they do. So they first draw the numbers as randomly the balls fall, and that comes up, and then they rearrange it to give you the numbers in ascending order, so it's easy for you to check your tickets. Then this was the outcome of the draw that was done on January 28, 2012, a while ago. Six correct numbers predicted. There was one winner who won 25 million rand. The people that won five correct numbers with the bonus, there were four winners, and each one of them won 176,172 rand, etc. We come down to the last one where we have three people that have won with three correct numbers, and you'll see that's 199,929, and they just won a mere 31 rand for their efforts. But as I say, you have to keep trying in order to win the lottery. Now, first question is, how many people won by choosing three correct numbers? Simple. As you can see, it is 199,929 people. We can read that from the information provided. The next question is 1.2. The probability of picking three correct numbers is 0.10855%. How many of the 26,099,614 people who played that week should have won? Show all working. So if we want to work out the number of people that should have won, so this comes back to what I spoke about earlier. We have a theoretical probability and an experimental probability. So theoretically, how many people should have won according to the percentage prediction there, probability, the probability percentage of the 26 million people that played the lottery. If you look at that, it means that we need to work out 0.10855% of the 29 million and 99,000 people. And if we look at that there, in 1.2, there has been a typing error. So we want to predict how many of the 29 million and 99,614 people that should have won. If we look at that, so we calculate our percentage of the 29 million and 99,614. There's also an error in the memo here. You can see I've corrected that. So it's as a percentage, we divide by 100 of 29 million, and we get 31,587,63, which is 31,588. We round that up. Now, as you can see, the number of people that won actually with three numbers is 199,929, while the prediction told us that it should be merely 31,588, which is a big discrepancy. So in 1.3, they asked why is there such a large difference between the number of people that should have won and the number of people who actually won. So that goes back to saying that our probability, theoretically, the outcome may not be the same as in the experimental outcome, like this lottery, which is where there's 29 million entries. And it showed that more people won that was than predicted. So the answer says that the probability is only a predictor and does not guarantee that a certain event will happen. So in this case, it worked out better because more people won compared to the prediction. So that's the lottery for you. So what we say that in taking part in the lottery, you have a chance of winning the six numbers, even though the prediction may say that it's a slim chance. There's one. That's a good one for you. In 1.4, the National Lottery website gives the stats of the number of times each number has come up. Here are the numbers of times each of the numbers that has come up in the past. So the number 4 came 145 times, number 5 150 times, and so on. The question here is that the average number of times each number from 1 to 49 has been drawn is 159 times. Do you think that it is odd that the number 25 has come up 142 times? So the number 25 came up less than the average. So it's similar to question 1.3. And if you look at this, we see that the numbers should be drawn the same number of times, ideally. So that is the theoretical. And the more lotto draws there are over time, the more this should be true. However, we can expect that some numbers to randomly come up more often than others due to it being a random draw. So coming back to that prediction, where 25 was fewer times drawn than the other numbers, like 4 and 5 and 6 and 39. So it tells us that because it's a random draw, anything can happen and your probability would go different to the theoretical. Right, lads, I hope you have enjoyed that session, and we will be back with our last part in probability, which is compound events. Bye for now.